I promised in the last lecture that we'd talk about exception handling next. And when something goes wrong in Python, it raises an exception object. So we saw an example with a dictionary in the last lecture. We're in this lecture creating another dictionary of elements where we're mapping the symbol to the name. And then this may cause an error in this code here. We're looping through a tuple of H and S, and then we're looking for elements symbol. So H is present in the keys of this dictionary and S is not. So we'll get a result for H, but then we get a key error S for when we try and look at elements S. Now, instead of looking for this symbol in the elements every time we loop through this, we could just run some code with a try except construct in Python. So this will naively try and run the code under the try clause. And if that works, great, no problem. But if it doesn't work, we will handle the error we get. And so this way we don't have to add in the extra performance hit of saying, is this key in the dictionary every time we loop through this, which might be a significant amount of computation if you have thousands and thousands of these. We're just going to say, do this. If it doesn't work, then we'll figure it out afterward under this except construct here. And so this is the same kind of problem we had before. We're running essentially the same loop, just with a try around this print statement. And so instead of getting an error with this big red text here, we just get the text symbol S not found in elements dictionary. And you could choose how to handle that differently as you like. Now Python defines a lot of exceptions, but you can also handle exceptions generically. So if you don't know that you're looking for a key error, for example, which is what you'd get if you don't have a key in a dictionary, then you could just have an exception or really just except. So this would also work if I took out key error. Maybe we don't want to say not found in dictionary because in this case we wouldn't know what the problem is. Symbol S has a problem. Okay, so in this case we've just caught all types of errors. And it's generally good practice to use things like except key error, because in that case you're kind of anticipating a certain class of errors. And if something else goes wrong, then you're not automatically assuming that it's the other type of error. So it's better for debugging your program and for ensuring it's working as you're expecting. And then you can also define a generic exception here. So this is the same idea, except you can capture the type of error with this as statement here, this as text. And then later on, as we'll look at classes, we can see how we can define our own custom exceptions.